I'm going to go over this section on adding and subtracting rational expressions. So the very first thing that we're going to be looking into is when the two fractions have the same denominator. What do? First thing that we need to do when the fractions have the same denominator, like for example a over b plus c over b, then what you do in this case when the two denominators are the same, you will add the numerators and put the answer over the same common denominator. Okay, then step number 2, and the end of it is going to be simplify this fraction if possible. Now, to simplify a fraction, like Ms. Rangel has already shown you, is you have to factor the numerator and denominator if possible, and then divide common factors. Okay, so let's begin with this. So right here on this fraction, we got the same denominator on both of these fractions, so we're going to add them or subtract them and put them over the same common denominator. So if I combine the numerators, you're going to get x squared minus 49. These are my numerators, as we can see right here. So we're combining those numerators and putting the result over the same denominator. Then we need to check, okay, can we simplify this fraction? To check if we can simplify it, we need to factor the numerator and denominator completely. So for the denominator, since it is a linear factor, so it is already x, and there is no greatest common factor or anything, so that one, x plus 7, there's nothing that we can factor from it. So x plus 7 is going to stay the same. Right? Now my numerator, let's go back to the definition of whenever the procedures that we can use when we factor a polynomial with two terms. This one of the two of the possibilities, or three of the possibilities, could be that you can factor a greatest common factor only, or maybe it could be that the two terms are difference of two squares, or it could be that it is a sum or difference of two cubes. So as we can see, the one that will be more applicable to this, it could be a difference of two squares, because we have a square on the x, so that will tell us probably a lot of this polynomial. So for difference of two squares, the way we factor it, I'm going to put it up here. So the formula is a squared minus b squared. So first of all, to identify whether this is a difference of squares, we need three things. The first value must be a square, the second value must be a square, and there must be a difference, which means a minus in between, right? So we need to find a number that when I square it, it equals to x squared, and that will be x, right? X times x will give me x squared. Also, I need to find a number that when I square it, or when I multiply it by itself, it equals to 49. So that will be 7, right? 7 squared equals 49. So looking at the formula, so if you remember, I'm going to put it on the very top. The formula is a squared minus b squared, and the factors of that will be in one parenthesis a plus b, and in another parenthesis a minus b. So as you can see, a is x and b is 7. So if we put them on the factor form right here, it will be a plus b would be x, which is a, plus b, which is 7, and in the other parenthesis will be a, which is x, minus b, which is 7. Okay? Then we have to see step number, we have to check if there's any common factor that we can divide out. And right here you can see that we got an x plus 7 on both the numerator and denominator. So that means we can divide out the x plus 7. And my final answer for this problem would be x minus 7 over 1. But we don't have to put the 1 on the denominator. Okay, we know there's a 1 on that denominator, so this is my answer. Okay? Let's go ahead and go to the next type of situation. Now we're going to identify when we have different denominators, how do we find the least common denominator of an expression? of two expressions. Question number 2, it says find the least common denominator, which is abbreviated as LCD, of the rational expressions. Okay, so to find the least common denominator, there's a couple of things we need to ensure. So for the least common denominator, the first thing is that you need to factor all denominators first. Second, you need to list all the factors from the first denominator and then step 3, you're going to list all factors from second denominator that do not appear in the list or that have not been listed. Okay? And that will give you your least common denominator. So, let's start off with this problem right here. Let's factor out the denominator of the first fraction. The first fraction gives you t squared minus x squared. Does that sound familiar? Definitely. This is basically your formula a squared minus b squared. Right? So you can remember that factors into a plus b in one parenthesis and a minus b in another parenthesis. Those will be the factors. Okay? So as we can see, a right here in this expression is t, right? And b is x. So using the difference of squares, we can see that we're going to get two parentheses, one with the plus, one with the minus, and the expression would be a plus b times a minus b. Knowing that a is t and b is x, you're going to write it as t plus x and t minus x. Now, let's factor out the second fraction. On the second fraction, this is a trinomial. So if you remember, you need, well, this trinomial does not have a number in front of the t squared. So that means all we have to do is look at the last number. The last number is a 1. And you need to find two numbers that multiply to that number. And at the same time, like right here, this means that when you add them, they give you the middle, which is my b, and that middle number is negative 2. Right? So 1 times 1 is 1, and 1 plus 1 equals to 2. But in this case, since it is a negative 2, both of them must be negative. Right? So negative 1 and negative 1. So we put those factors on the parentheses. Then the t squared factors into t and t. Right? And there's only one little thing. Since that one has an x squared at the end, you're going to break up that x in each parenthesis on the right side, right next to the 1s, into an x and an x. That way, if you multiply them, negative 1x times negative 1x is positive 1x squared, which is what we see right here. Now, just keep in mind that we don't have to put the 1s, right? So the 1s are not required. So these fractions are going to have the following denominators. t plus x, t minus x on the first denominator, and the second fraction, you're going to have a t minus 1x is the same thing as t minus x, and t minus x. Okay? So according to the rule, if I want to find my least common denominator, which we abbreviated LCD, we're going to list all of the factors from the first denominator, which is t plus x and t minus x. Okay? but also you need to list any factors from the second denominator that we have not listed. For example, we already listed the second denominator has t minus x, so we already listed one of those t minus x's, right? But this second denominator has another t minus x, so we need to add it to the list. Okay, so we already listed one of those t minus x's, so we do not repeat that one, but that one has an additional t minus x, so you need to include it in your denominator. So remember, the rule says factor the denominator, then you list all of the factors from the first denominator. We did that. And then we're going to list any factor from the second denominator that does not appear on the list. So we already listed one of those t minus x's, but there's an extra one that we need to include in the list. Okay? So how can we better rewrite this expression? We can rewrite it in a little bit of a different way. Since we got 2t minus x's in that expression, what would that equal to? T minus x squared. And that will be my least common denominator. Okay. Alrighty. So, now, next question. The next problem we're going to do, now we're going to start adding those expressions with different denominators. Okay? So we got 8 over x minus 9 plus x plus 1 over 9 minus x. Perform the indicated operation, which is addition. Now, there is only one little thing that I do need to mention. These factors, they look different. They look alike, but they're not exactly the same, right? If I tell you 2 minus 3 is not the same thing as 3 minus 2. Let me just give you an example. Like if, for example, we got the number 2 minus 5. 2 minus 5 is negative 3. Right? And 5 minus 2 is positive 3. The only difference between those two numbers is that one of them is positive, the other one is negative. So it is exactly the same thing in these expressions. One of them is the opposite of the other one. So the opposite means that one of them has a factor of negative 1 compared to the other one. So what we can do is this. We're going to modify the second denominator. We're going to modify to make it look exactly the same as the first denominator. And all we have to do is we're going to divide or factor out a negative 1 from the second denominator, and then it's going to look exactly the same. So my first denominator is x minus 9. My second denominator, if I factor the negative 1, then remember when you factor it, it's going to go to the outside of the parentheses. You're going to put a parenthesis and you're going to put it on the outside. So if I divide that negative 1, then that's going to become negative 9 and positive x, right? So that gives you a negative 9 and a positive x. If I factor that negative 1, so that's what's going to go inside the parentheses. But I'm just going to rewrite it. Negative 9 plus x will be the same thing as x minus 9. And which is what I was saying right now. Those two denominators are almost the same. The only difference is that since they have a minus and they're backwards, one of them has a factor of a negative 1, so compared to the other one. Okay, so these are my two denominators that we can see they're almost the same, but one of them has a factor of a negative 1. So what we will do is we're going to find first, before we can add these two fractions, we're going to find the least common denominator. So according to the rule, list all denominators from the first fraction. The first fraction has a denominator of x minus 9, and then you're going to list any factor from the second denominator that you have not listed. X minus 9, that one I already listed it, right? So the only thing that we have not listed from the second fraction is the negative 1. So that will be my LCD. Negative 1 times x minus 9. So let's put that on my new denominator. Just keep in mind that you don't have to put negative 1 whenever you put your final answer. Negative 1 would be the same thing as just putting a negative in front of that parenthesis. We know that there's a 1 just by putting a negative. Okay, just keep that in mind. For right now, I'm going to leave it there, but at the end, we're going to remove that 1. We're just going to keep that negative. Okay, so what do we have to do to make them have the same denominator? This is the next part of the rule. You need to make sure that, for example, x minus 9, this denominator is exactly the same as my least common denominator, which is negative 1 times x minus 9. So to have the least common denominator on this fraction, what are we missing? We are missing the negative 1, right? So what you need to do is you're going to multiply both the numerator and denominator to make it equivalent. You're going to multiply by a negative 1. So that way we can keep it balanced. So whatever you do to the denominator, you have to do it to the numerator as well. So that way we keep that fraction balanced, equivalent. Okay? So if we multiply by a negative 1 on the numerator, we get negative 8, right? And now you see that both of the fractions have the same denominator, right? So now we can put them both together. So negative 8 plus, and then I'm going to transfer this other numerator to this new fraction, because that fraction, if you notice, it already has that common denominator, least common denominator that we need, right? So we just need to transfer the x plus 1 to the fraction. Okay? Then what? Then what we're going to do, we're going to combine the like terms. As you can see, we can actually combine these values, negative 8 and positive 1, they're like terms, right? So negative 8 plus 1 is negative 7. So my final answer for this will be x minus 7 divided by negative 1, but remember that we don't have to put that 1, so we can just put that negative times x minus 9. And there's nothing that we can simplify because the x minus 7 and the x minus 9 are not common factors, right? So that means this is my final answer. Next question. Now we're going to subtract these two fractions. So the first thing, as usual, we need to factor my denominators, okay, before we can find the least common denominator. So the first denominator, you see that both of these terms have an x. So that means that we need to factor a greatest common factor of an x from both of them. And when you factor greatest common factor, you need to divide it from both of them. So if I divide the x, we're left with x minus 8 inside of the parentheses. And that's it, right? Because x minus 8 cannot be factored more. Now, let's go to the second denominator. The same thing is going to happen to these. As you can see, both of them have x. But in this case, the maximum number of x's that I can factor will be x squared. So we're going to divide the x squared from both of these factors, and we're going to put the x squared on the outside. Okay? And then x cubed divided by x squared is x minus 8, right? X squared is cancelled, so you get an 8. So I'm going to rewrite my fractions. So we're going to have negative 6 over, that's what we're going to get here, x times x minus 8, and then minus 5 over x squared times x minus 8. So let's go ahead and find the least common denominator right here. I'm going to write it, let's say, all the way up here. Okay. Least common denominator. We need to list all the denominators from your first fraction. Your first fraction has denominators of x and x minus 8. Right? So we already listed the x and the x minus 8. Now you look at the second fraction. You already listed the x minus 8, but the only difference on the second denominator, what do you see there? You have an x squared. So x squared means that you have two x's, right? I listed the x minus 8. I listed one of those x's on my least common denominator, right? Those are the two things that we have on my LCD, but we are missing the other x. So that means I need to include that other x. So if I put another x right here, that's going to be an x squared. So that is my least common denominator. Okay. List all the factors from the first denominator, which was x and x minus 8. We did that. But then that second denominator, we need to list anything that we have not listed. That one had an extra x that we didn't have. So we have to include it in there. So that x times x will give me my x squared. Okay? Now, we are going to begin with the process of subtracting those two fractions. So my denominator is going to be x squared times x minus 8. So if I want my first fraction to have this denominator, what is the only thing that we're missing on the first fraction so that we can have an x squared and x minus 8? We already have an x minus 8 and we already have one x, so we need another x. So we can make it an x squared, right? So what we need to do is multiply both the numerator and denominator by another x. Okay? And now you see that this is going to become an x squared, and my denominator is going to be exactly the same as my least common denominator. So let's go ahead and write the numerator. The numerator gives you x times negative 6. Let's bring it to the side right here. That's negative 6x. Okay? What about my second denominator? Second denominator has exactly the same as my least common denominator, right? So this is the same as this already, right? So what is it? The only thing we have to do, we just need to bring over that 5, but just keep in mind, be very careful because it has a minus in the middle. So in other words, you need to bring over that minus 5 to my new fraction. Okay? So the numerator cannot be factored. The denominator is already factored. And ask yourself this question. Is there any common factor? Like, for example, can I simplify the 6x minus 5 with the x plus minus 8? Or can I cancel out the negative 6x minus 5 with the x squared? No, right? So that means this is my final answer for this expression. Next, let's go ahead and subtract these two denominators, okay? These two fractions. So on this one, what do you notice? Both of them have the same denominator, right? So what does that mean? That is my first rule. When the denominators are the same, all I have to do is put the answer, combine the numerators and put the answer over the same common denominator, right? So my common denominator will be 7x minus 4, and all I have to do is transfer my numerators. So this is going to be a 4x right here, but then be careful because you have a minus right here, and then you are going to subtract everything that is in this fraction. So you need to be careful when you subtract x minus 2, you need to put it in parentheses because everything in that fraction must be subtracted. So you need to multiply both of them by that negative. Okay? So what are we going to get if we multiply them by that negative? We're going to get 4x. Of course, we're going to bring the 4x down. And if I distribute that negative, we're going to get negative times x is negative x. And negative times negative 2 is a positive 2. Over my common denominator, which is 7x minus 4. Then we're going to combine like terms, right? As we can see, we can combine the terms 4x minus x, which is the same as 4x minus 1x, right? 4x minus 1x equals to 3x, then plus 2 over my common denominator, which is 7x minus 4. Since we cannot factor the 3x plus 2 and we cannot factor the 7x minus 4 and they're not the same factors, this is my final answer. Next problem. Now we are going to add these two fractions. Okay? Remembering one more thing, this question is also asking you to provide the excluded values or the values that are not in the domain of these rational expressions. So for example, how do I find the values that must be excluded from a rational expression? A fraction cannot contain any value of x that makes the denominator equal to 0, right? So how do we find that? Very simple. We just have to equal this denominator to 0 and solve for x. Equal this other denominator to 0 and solve for x. So if I solve for x, I have to add the 5 to both sides. So what do we get? That x is equal to 5. So that means that the number 5 cannot be on my substituted into this fraction. Why? Because it causes my fraction to have a denominator of 0, and remember that denominator of 0 makes the fraction undefined. Undefined means that the value does not exist. So we're going to say that x cannot equal to positive 5, comma, and now we're going to solve for the other one. We subtract 3 from both sides, so we get x is equal to negative 3. So negative 3 is going to make the second fraction to have a denominator of 0. Negative 3 plus 3 is 0, right? And 7 divided by 0 will give you an undefined value, which means a non-existent value. So that means that x cannot be positive 5 or negative 3. That will be my domain. Now, let's go ahead and add these two fractions. Now, as you can see, you cannot factor any of these two denominators because both of them are x and both of them are x, right? There's nothing we can factor. So all we have to do is list your least common denominator. So your least common denominator, you need to list any factor from the first fraction, any denominator from the first fraction, which is x minus 5, and any denominator from the second fraction that does not appear in the list or that you have not listed. You have not listed the x plus 3, right? So you have to add it to the list. So basically your LCD will be x minus 5 times x plus 3. Okay? So that's what my two denominators must have. X minus 5 times x plus 3. So I need to make sure that both of these denominators have that. You see right here that we already have an x minus 5 on that denominator, right? So what are we missing? The x plus 3. So what you need to do to complete it, you need to multiply both the numerator and denominator by that missing factor, which is x plus 3. And then it is the same denominator already, so what we can do, we can just transfer this numerator over to my new fraction. You can put the 4 in the front if you want to, so that's okay. 4 times x plus 3, it is the same thing as x plus 3 times 4, right? So then let's do the same thing for my second denominator. You see that my second denominator has an x plus 3, right, which is that. So what are we missing from that least common denominator? The x minus 5. So we need to multiply both the numerator and denominator by that x minus 5. And now you see that the denominator is exactly the same as my LCD. So we can put that expression of my numerator into my new fraction. Keeping in mind that there's a plus in the middle, right? Plus 7 parentheses x minus 5. Alrighty. So simplify these expressions. We're going to distribute, right? So right here we're going to distribute the 4. 4 times x and 4 times 3 is going to give you 4x plus 12. Then on my second one, we're going to have 7 times x and 7 times negative 5. 7 times x is positive 7x. 7 times negative 5 is negative 35. Everything over my least common denominator, which is x minus 5 times x plus 3. Combine like terms, right? That will be the next part of the process. So we can see that we can combine the 4x and the 7x, and we can also combine the 12 and the negative 35, right? So if we combine them, what are we going to get? (4x plus 7x) is 11x plus, not plus, because 12 minus 35 is going to be negative 23, right? Everything over my common denominator, which is x minus 5 times x plus 3. Can I factor anything here? 11x and 23 cannot be factored, right? And the denominator is already factored, and there is no common factors on the numerator and denominator. So that means this is my final answer. This and my domain, those are the two answers that the question is asking. Okay. Next question. Now we are going to subtract those two fractions, and we are going to also find the domain, okay? The values that make the denominator 0, the values that we must exclude from the fractions, okay? So we are going to begin by factoring the denominators. So on this denominator, you see that the value in front of the x squared is a 1. So all we need to find two numbers that multiply to c, which is my last number, which at the same time, they add to the middle number, which is b, 4, right? So it's 3 times 1 multiplies to 3 and adds to 4, right? Just keep in mind that it has to add up to negative 4, so both of them must be negative, right? So it would be negative 3 and negative 1. Those are my factors from the first fraction. Second, we're going to do the same thing. Since the value of in front of the x squared is a 1, all we need is get the factors of the number c, which is the last one, two numbers that multiply to c. But right here, this minus means that when you subtract those numbers, they give you a 2. So it's 3 times 1 subtracts to 2, right? So we're going to open up two parentheses again. For this one, we're going to put x and x on the front, and then the 3 and the 1. Remember that the biggest number carries this sign, so since this is a negative, so it has to be a negative 3, and negative 3 plus 1 equals negative 2. Okay? So, I'm going to rewrite my fractions as usual. So we're going to have x over, then my new denominator right here is x minus 3 times x minus 1. Then minus x over, and my second denominator has x minus 3 times x plus 1. Okay? So what we need to find first is my least common denominator. List all of the factors from the first denominator, x minus 3 and x minus 1, right? Those are my factors from my first denominator. And any factors from the second denominator that I have not listed. So I already listed the x minus 3, right? Which one am I missing? X plus 1. So I need to add the x plus 1 to my list. Okay? Next. Now we need to see what we need to add to those denominators. For example, the first denominator has an x plus 3, right? I mean x minus 3, which is this. And we have an x minus 1, which is this. What are we missing? The x plus 1, right? So we need to multiply the x plus 1 on this fraction on both the numerator and the denominator, right? And now, since my new denominator on the first fraction is already the same as my least common denominator, I'm going to bring that numerator over to my new fraction. Okay? Now, second one. You see that we have an x minus 3 on this fraction, right? And we also have an x plus 1, which is this one. What are we missing on that fraction? X minus 1. Right. So we're going to multiply the numerator and denominator by the x minus 1. And since the denominator is already the same as my LCD, I'm just going to bring this numerator over to my new fraction, keeping in mind that there's a minus in the middle. Okay? Minus x times x minus 1. Now, what are we supposed to do next? Distributive property. Right. So the next thing would be distribute that parenthesis on the numerator. If I multiply the x times the x, we get x squared, right? Then x times 1, you get 1x, which is just plus x. Then we are going to distribute the second one. Negative x times x is negative x squared, and negative x times negative 1 is positive x. And then we're going to put that over my common denominator, which is x minus 3 x minus 1, and x plus 1. Then we can combine like terms. That will be the next thing, right? So we can combine x squared minus x squared, and also we can combine x plus x. X squared minus x squared, since they're opposites, these two, they cancel out, right? 1x squared minus 1x squared is 0x squared, so they cancel out. And then x plus x is going to be 2x. And there is no factors that we can divide, right? We cannot simplify the 2x with any of my denominators. So my final answer is going to stay like that. Okay? To finish this question, so that will be the answer that goes right in here. We still need to find the values of x that need to be excluded. Right here means that the values of x that x cannot equal to. Those will be the values that make my denominator 0. So let's go ahead and finish this problem by doing that. So solve for this denominator. X minus 3 equal to 0. X minus 1 equal to 0. And also my other denominator, x plus 1 equal to 0. Solve for x, and we're going to find the values of x that x cannot equal to. So if I add 3 to both sides, you get x equals to 3. If I add the 1 to both sides, you're going to get x equals to 1. And if you subtract this 1 to both sides, you're going to get x equals to negative 1. So these are the three values of x that needs to be excluded from the domain. So you're going to say that x cannot equal to 3, comma, 1, comma, or negative 1, because those are the three values of x that make the fraction undefined, which means that x cannot contain those values in its domain. Last question. We're going to subtract these two fractions to finish up the lesson. Now we need to factor those denominators so we can subtract these two fractions. So we're going to factor them the same way. This one, the value in front of the y squared is a 1. So all we need is get two numbers that multiply to c, right? That when you subtract them, they equal to 2, 3, and 1, right? So when we factor this out, we're going to get y and y on each side, and then the values 3 and 1. Biggest number must be negative, right? That's a negative 3, and negative 3 plus 1 equals to negative 2. Second denominator, as you can see, this has two terms, and it has a difference in the middle, and the first one is a square. So it might be that this is a difference of two squares. Difference of two squares, again reminding you of the formula, it is a squared minus b squared. A squared minus b squared, and the factors of that is a plus b in one parenthesis and a minus b in the second parenthesis, right? So we need to find what square equals to y squared? Y. What square equals to 1? 1. So that means that on this equation, a squared minus b squared, a is equal to y and b is equal to 1. So my factors for this denominator would be a plus b, which is y plus 1, that is a is y and b is 1, times a minus b, a is y minus b, which is 1. I am going to rewrite these two fractions. Okay. So my new fractions that we're going to get is y plus 3 over, then my denominator becomes y minus 3 times y plus 1. Then we have a minus. My second fraction is 7 over, and my second denominator is y plus 1 times y minus 1. Let's first find the least common denominator. you need to remember to list all of the factors from the first denominator, which is y minus 3 and y plus 1, right? And then, according to the rule, we need to add list any factors from the second denominator that have not been listed or that do not appear in the list. So we already listed the y plus 1. We are missing the y minus 1. Okay, so then let's go ahead and finish this problem. So we need to make sure that both of these denominators have these three denominators. Okay, so on the first denominator we have y minus 3, we have a y plus 1, we are missing y minus 1, right? So what we need to do, multiply the y minus 1 both on the numerator and denominator. Be careful on the numerator, because the y plus 3, everything has to be multiplied by the y minus 1. So put it in parentheses. So now that we have the same denominator as my LCD, we can go ahead and write this numerator right here on my new fraction. Now we have a minus in the middle, right? So let's bring this minus over. Then we need to do the second part of this problem. Now let's take a look to the second denominator. We already have a y plus 1 in this denominator, right? And we also have a y minus 1 on that denominator. What are we missing? Y minus 3. So that means that we need to multiply the y minus 3 on the numerator and denominator of this second fraction. And you can see that now we have all of the three factors from my LCD on this fraction. So we can just bring this numerator over to my new fraction. I am going to rewrite this so you can see better what we have so far. So, what do we need to do to simplify that? The numerator we need to FOIL, right? So we're going to multiply y times y, which is y squared, y times negative 1, which is negative 1y, then 3 times y, which is a 3y, and 3 times negative 1, which is negative 3, and then we distribute the last parentheses. Negative 7 times y is negative 7y, and negative 7 times negative 3 is positive 21. Everything over my least common denominator, which is y minus 3, y plus 1, and y minus 1. Then we combine the like terms, right? So we're going to combine these y's right here and that y, and also we can combine the negative 3 with the 21, right? Give me 1 second. And the negative 3 with the 21, right? So that's what we're going to combine. So the y squared stays alone. Then negative 1y plus 3y right here, this gives you 2y, right? But then 2y minus 7y is negative 5y. Then the other two numbers, negative 3 plus 21 is positive 18. Everything over my common denominator, y minus 3, y plus 1, and y minus 1. So what we need to do at last, we need to check if we can simplify this fraction. The denominator is already factored, but the numerator, we need to check if we can simplify that numerator, or we can factor it to see if there's anything that we can divide out, right? So how do we factor that trinomial? A trinomial, you always factor it by looking, okay, first of all, since that y squared doesn't have anything in front of it, we just need to get the factors of the 18 that multiply, numbers that multiply to 18, and that when you add them, they give you a 5. For example, 1 times 18, those are factors of 18, but do they add to 5? No. 2 times 9, factors of 18, right? But 9 plus 2, do they give me 5? No. 3 times 6, those are factors of 18, but 6 plus 3, does that give me 5? No. And are there any other factors of 18? There are not, so that means you cannot simplify it, and thus your final answer is, stays the same, y squared minus 5y plus 18 over my least common denominator, which is y minus 3 times y plus 1 times y minus 1. And this is the end. Okay, so we are finished.